All right. So yesterday at the end of the day, you were scattered back at the back and we were looking at the pairs, yes? Because remember that forces always come in pairs. They always come in pairs. It's sad that Haley was the one that was super excited about that. And we miss you, Haley. Anyway, okay, so we had a bug smashing into a car windshield. We had bowling balls and bowling pins smashing into each other, and who's over here? Who's over there? What was it? What kind of objects were we talking about?
Frog and a table.
Frogs and tables. There we go. All right, sweet. And so at the very end, before we ended, what did I ask you to do?
Look for the asterisks.
We looked for the asterisk and then draw it. What did I ask you to draw?
Freebody diagram.
The Freebody diagram, right? So just the friendly reminder of that. You may just want to write this down because you probably didn't write this down since you were way at the back before. You don't have to write this down because you have it somewhere in your notes. But just the friendly reminder that a free body diagram is a diagram of one object. One object and all the forces that are acting on that object. Okay? So with the frog situation, the frog was sitting on the table, if that sounds familiar to you. And we've got the force of the table on the frog labeled, pushing up. What do you guys think about that? Is that okay?
Do you guys like my ugly frog?
It's adorable. And the force of the earth acting on the frog pushing down, yes? Is this a free body diagram of the frog? Yeah. It's all of the forces acting on the frog. So that's awesome, right? It's all the forces acting on the frog. Now, I have a question for you. I want you to think about this very carefully before you answer it. You ready?
No.
Well, get ready. Here it comes. Here's my question. Are these two forces acting on the frog a Newton's third law pair?
No. Because it would be the force of the table on the frog and the frog on the table.
That would be a third law pair. Did you guys catch what she just said?
Yep.
Okay. I will tell you that it's not one of those. What's that? Absolutely. I'm gonna give it to you in a little bit more context. If you ask, and it's not like you're going to go around to somebody on the street and be like, hey, is this a Newton's third law pair? Because they would just look at you like you were completely nuts, right? But if you ask physics students that are not like in the zone, a lot of them would say that these two are a Newton's third law pair. Why is your gut reaction, yes, those are a third law pair? Because they're opposite of each other, right? They're opposite of each other. And how do the magnitudes compare? They're equal, right? They're equal and opposite, so they have to be a third law pair. Wrong answer. And the reason is, so Maddie just said, what would be the third law pair? What would be the thing that would be the pair for the table on the frog? Frog on table, table on frog. You're just switching those words. Are you with me there? Okay. What would be the Newton's third law pair for the earth on frog? Frog on earth, earth on frog. Are you with me here? Okay. So the moral of this story, the thing that I really, really want you to remember, these are a third law pair. Okay. A on B, B on A. Will you ever have a Newton's third law pair in a free body diagram? I'm going to repeat the question. Will you ever have a Newton's third law pair in a free body diagram? Dylan, you are saying no with a lot of gusto. Why are you saying that?
Because they have two objects.
Yeah, that was ours.
Right? They have to have two objects that are flipped, right? So let's just write that down and then we'll look at these other ones here, okay? So we will never have a third law pair on a free body diagram. Is that okay? Some of you were saying that with gusto and felt like that was okay, and then some of you didn't really say much. And I want to make sure that sits okay. Thank you, friend. How are we doing? Does that make sense? As long as you don't look convinced yet.
Yeah, no, it's just like, okay, so what do you mean by like one object and forces on that one object? Like, does it care?
So anytime you have a free body diagram, like all the free body diagrams that we've been drawing for the last month and a half or whatever, okay, it's always been one object and all of the forces. So it's been the earth on the box and the string on the box and the table on the box and the the surface on the box and the monkey on the box and the frog on. Are you with me there? It's always on the box. Is that okay? A third law pair is going to be something on the box and the box on something. Is that okay? Does that make more sense? Does that help a little bit?
Yeah, like I know what you mean. It's two different.
Yeah. It's a little bit weird just because they're very similar ideas, but they also are very, very different. Okay, so let's do the bug here. And people were reacting, and here's the thing, ladies and gentlemen, am I grading you on this? No. Are we using this as learning opportunity? Yes. So let's take a look at this picture. So we've got a bug. This is an adorable bug, by the way. I don't know who drew it, but it's super cute.
Thank you.
You're welcome. Got the force of the bug on the earth, the force of the car on the bug, and you've got the earth on the bug.
Can we correct it before you guys grade us on it?
Yes. Tell me what you have now realized. What adjustments do we need to make?
We have bug on earth, earth on bug.
Oh. And what do we need to do about that?
Take off.
Take off the top one. What do you guys think? Does that make sense? Take off the top one? Harley doesn't look convinced of that.
No, I think I got something confused in my head.
Talk.
Don't you use pen? You don't like colors?
So like,
Shh,
is
guys.
what we've been doing for a while not correct then?
They're two different things. So, and this is why I want to have this conversation. So the free body diagram labels, let me write this down too. The free body diagram labels will always be the force of something on the object. Does that make sense? The force of the floor on that object. Are you okay with that? So what I think Tatum is saying is, this one says force of earth on bug. This one says force of car on bug. So these are both acting on what? Bug. This force that we drew here is acting on the earth. So does that force exist? Absolutely, most certainly it does. But it isn't acting on the bug. Does that distinction make sense to you? So this force absolutely exists, but it's not acting on the bug. Yeah. How are we doing? Is that okay? Okay. So I'm glad that you made this mistake. Part of the reason that we do the activity the way we do is because I like that conversation, because if we just drew them all together. I do. You learn so much more from mistakes than you do from not mistakes, right? I'm sure your teachers have told you that before. If they haven't, let me tell you that for everybody now. All right. Let's take a look at this one. Bowling pin. And the bowling pin was the thing that had the asterisk next to it, right? For the bowling people. Is that true? Okay. So let's take a look at this one. So we've got the force of the lane on the bowling pin. Is that okay? Sure. This is the force of the bowling ball on the bowling pin. Is that okay? Sure. The force of the earth on the bowling pin. Is that okay? Yeah. On the bowling pin, on the bowling pin, on the bowling pin. As long as it's on the bowling pin, life is good. But there's one over here that says the force of the pin on the ball. That one shouldn't be there, right? That one is a third law pair with this one over here.
Oh, but then you're doing free body. I'm like, this is third law.
Right, do you see like I'm trying to kind of mash them up this is like, do you really get it? Like, this is deep thinking stuff here. So we're going to take this one off, and now we've got the free body diagram.
You use the third law.
Good, I love that. See, it's like I paid you to say that. I'll just, no. Nice work. When do you use the third law pairs? Well, I mean, it depends. Sometimes they will ask you a question, and the way the question is worded, you just have to use the third law pair. So maybe there's an example that says, Gerald applied a force of 30 newtons to the desk. Blah, 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 blah. And then maybe it asks about the desk. And then maybe it also asks about Gerald and says, what force did the desk apply to Gerald? Then you're going to use the third law pair. Does that make sense? But generally, you don't use the third law pair to do figuring. It's just a like awareness thing. Yeah. Does that make sense? Yeah. It's a kind of a funny question, which is why I like to do it totally separate from the other one. Yeah. All right. Life is good? Okay. All right. We're going to do a couple of problems to kind of see how we're doing. I'm just going to make sure. Okay. I like this one because it's called the potato problem. Who doesn't like
It's me. Oh.
what?
It's me.
I look like potato.
Okay, I'm just gonna smile and nod. I would, if I was gonna characterize you as an inanimate object, I don't think potato is what I would have chosen.
My face.
That would be a great next.
Background.
No. All right, let's move on to happy things. A potato with a weight of 2 newtons is resting on a table. A student makes a number of statements about the situation. There are 4 of them. So what I want you to do on your notes, because we're gonna take a few notes here, is write potato problem or potato example or potato something, A, B, C, D. And for each of them, we're gonna do this individually first, and then we'll discuss it. Is that okay? So here's the first example. The weight of the potato is a force of 2 newtons exerted by the earth in the downward direction. Is that true? Or is there something wrong? So you can say it's true or it's not. This is what got messed up. So I'll give you just a minute.
What did they say?
The weight of the potato is a force of 2 newtons exerted by the earth in a downward direction.
Just true or false?
Yep, true, or I would say true or false, and if it's false, tell me why. I'm going to move to B. If you're not quite done with A, I'll come back to it. Is that fair? Okay. Because maybe sometimes it just kind of takes a little while to get your brain in all of this. Ooh, they said reaction. I hate that, right? The force pair is what they really mean. So let's fix it. The force pair to this weight or the force that goes along with this force, weight of 2 newtons exerted by is a force of 2 newtons exerted on the potato by the table in an upward direction. Do you agree with that? Or do we need to fix it?
I think I get it. Either I know this or
That's why we're doing it.
so I either know this, I feel like I know.
Yeah.
Or no way.
Totally confident.
Okay.
I'm really confident.
Yep. So there's A again, and then I'll go back down to C and D in just a sec. So A says the weight of the potato is a force of 2 newtons exerted by the earth in a downward direction. So force of the earth on the potato. Can I scroll up? Is that okay? Or scroll down, I guess?
So,
Question B was the force pair to this one, to this weight, is a force of 2 newtons exerted by the potato, or excuse me, on the potato by the table in the upward direction.
It's right because it can't.
Hold on, let's Let's go to C.
Oh, can we answer them one at a time?
Yeah, I just want everybody to look at them all, and then we'll go through them one at a time. Yes. The normal force exerted on the potato by the table is a force of 2 newtons. The force pair for this is a force of 2 newtons exerted on the potato by the earth in a downward direction. And if you need to write out things, like if the wording here is kind of strange, you can write it out so that it makes more sense to you. Are you ready for D? Not quite yet. Okay, sorry. And we'll give you time to discuss them too in just a minute. I think it's good for you to process individually one at a
Can we
time.
go back to the first one?
Nope, I'm gonna go down to D first.
Let me know that.
4. One more. If the 2 Newton potato is lifted off the table by a hand that exerts 4 newtons upward on the potato, the force pair to this 4 Newton force is a 4 Newton force exerted on the hand by the potato in a downward direction.
Oh, this is a new one?
Sorry.
Yeah, that's okay.
Give you a couple of seconds to process that, and then we'll discuss A. Okay. And we'll think about B. Okay. Can we go up? Yes, you may, quickly.
Run.
You don't need to run. Okay. At your tables, discuss A. Go ahead and have a conversation about that. Besides spelling.
Okay, I said it's incorrect. Why? Because they don't have mass.
Joe, put your phone away,
And the
sweetheart.
earth doesn't.
Oh, I said true.
What is it? What was the
I
question?
said true for the first
What is
three
it?
and then
It
false.
says on the earth is,
I said
it says the weight of the potato. The
true.
earth? This is the weight of the potato. Is a force of 2 newtons.
I'm just.
Exerted by the downward direction. Wait, shoot, wait.
Yeah.
Oh, okay. Yeah, I guess, yeah, no. Oh, okay, yeah, that makes sense. Then it'd be false, yeah, but I thought it was just not like, the earth is exerting force 2 newtons of force because the potato's not. That was the case of true, but in your case was false. So in other words, we got no fair.
Why'd you say false?
We can both be correct. Yeah, no, I think you're right though, because it just say the weight.
Potato with.
It might just be like that, it just weighs enough that egg.
The weight of potato.
Not
Oh, I have to
that.
wait
Because it's not,
I don't know.
downward. I thought it was like upward or something like that. The weight of the potato is a force of 2 as if it was by earth.
Let's say, very correct, they don't have a mass. So.
Like gravity?
I thought it just meant like.
That's what I'm saying. It's like.
The earth is the thing.
You missed our conversation when she told me that it is true.
All right. All right, let's talk about A, ladies and gentlemen. I think maybe the key here is just the word weight. We've talked about that word before, right? What does weight mean? We don't use that word a lot, but what is it? What's that? You're close. Mass doesn't ever change. What is it that changes? The force, right? So if you were second guessing yourself, if you're like, I don't know, let's write it down right now so we don't forget. The weight is the force of the earth on an object. In this case, that object is a potato, okay? Knowing that may change your answer. May not, depending on where were you at before. The weight of a potato is the force of 2 newtons exerted by the earth in the downward direction. What do we say? Yes? No? Is that one true?
That's true.
It is true. Yes. Okay. So here's my potato. That's a really lumpy potato. And there's a force of the earth on the potato, and it acts downward. Life is okay for A? Okay. All right, let's do B. Have a conversation at your tables. Go.
Okay, so I think false because, so this part is.
No, that's true. Because.
Talk about it, talk about it, talk about it.
Table on
And
potato.
table is moves upward. Wait, no, actually.
And the potato are like two.
Wait, no, then wouldn't the table be more? Then the potato would be on half.
So the
Potato on.
fourth pair, the third law pair,
Potato on.
two, the weight would be.
Yeah. But then, no, I thought it just meant like, wait.
Oh, that was the first one, yeah.
Yeah.
Oh, okay.
So.
Wait, what are these statements about? Just like a situation, like a free body diagram? Because the free body diagram is like just talking about situation. Because then if it was more, the potato would go back.
And I said.
It is so
because I was thinking
If it was
this
less, the potato would be
and
taken.
it said first in the
It
first.
just stays on the table.
Yeah.
Then obviously.
He is
Referring to the weight.
And isn't there a concept of Yeah, it makes you.
You take a picture of it, you know, save it. Put it on your desktop. It's really good. All right. How are we feeling about B? True, false? What do you think? Thumbs up, thumbs down. Give it, show me, show me. It's true, it's false. True, it's false, I guess. You guys are like divided over here?
We're a house divided.
A table divided? How are you guys feeling over there, Magda? False?
Literally.
How are we feeling over here? Oh, that's not the right answer. Okay. Yes?
I think the word that's throwing me off is the word weight.
Okay, so let's change it. Let's change it. This is like where we're learning, right? This is one of those things that like
Well, it means F earth on an object.
it does.
But, so then there's the potato on the table. It
Uh-huh.
also has, the potato is being pulled by 2 newtons down.
Yeah, so that's why I gave you a sheet. So go ahead and draw yourself a potato on your whiteboard that I just gave you. Okay. So the force pair to the weight, they used weight on purpose here, right? So that you had to translate that to earth on potato. The force pair to the earth on the potato, this should be really easy, friends. If it says earth on potato, what's the force pair to the earth on the potato? Potato on earth. How big is the force of the potato on the earth? 2 newtons. The force pair to the potato on the earth should be the force, or excuse me, earth on potato is potato on earth. That should be 2 newtons, right? Is that what this student claimed? No, they said the table. Exerted by the potato on the table, or excuse me, on the potato by the table. So the answer to this one is false.
Easy, I had it from.
Who's unhappy?
Oh, wait, I get it.
Gerald, why are you unhappy? Talk to me. Oh. Okay.
Okay, wait, it's false because it's talking about the table and we're not even talking about the table, right?
Yes.
Okay.
Okay, so Gerald, let me help you out. So the force of the earth on the potato. Part of this was the stuff that we talked about the last couple days. So the earth on the potato, there's a Newton's third law pair. We talked about this a little bit. I'm going to go back up here to look at our picture here. It's this box that we have to pay attention to. Force of A on B, force of B on A. That is a third law pair. You just switch them. You with me? Okay. That's the way you get a third law pair. No other way. Okay. So you just have to switch those labels. So now if we look at that, what does it have to be if this is earth on potato? If it's earth on potato, what's the third law pair going to be? Boom. There you go. They're claiming it's something else. They're wrong.
Yeah, don't even speak about it. Send out the hall.
It's true.
Without your phone.
I love the caveat that you guys are
And
without your phone. Oh man. Yeah, and without your McFlurry. That's true. All right, do C. Talk about it with your table mates. Go.
And then fudge.
Oreo. Yeah, I said false.
This is the most disgusting.
Discuss. True and false, and if it's false, tell me why.
The pair force.
What does it say?
No, false.
Potato by the table.
I'm not sure. That would go in A.
No, Gerald, you wrote false. Oh, wait, I lied.
Does the table is actually reaction?
The reaction.
You guys are saying that R word an awful lot. That's not what you mean, right? You don't really mean that.
I do too. That one's your favorite.
All right. Are you guys in agreement over here?
Yeah, we are here.
Yeah? There aren't any phones out, are there? Abdul? Away, away, away. We doing okay? We in agreement? Yeah? All right, I don't want you to fall asleep. Don't tell me what you got.
Okay, so I actually said true, but they kind of explained it to me.
Okay.
So
They've convinced
they're
you?
going in opposite directions, like one's
Okay, shh, guys. Shh, 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 shh. Please be quiet. Go.
so one's going up and one's going down, but the table is the other factor that is put in there,
Okay.
which is not causing it to be very
Or this time it adds in the earth, which is not the third block pair to the table on the earth. Or
So-
the table on the potato.
On the potato by the table. That's one force, right? The reaction to this is a normal force on the potato by the earth. All you have to look at are those little prepositional phrases. Are you with me there? Okay. On da da by da da. On da da by da do. You with me?
My favorite lesson in grammar. Yeah.
Prepositional phrases? Me too. I love them. Did you have to memorize the prepositions? Like recite
I
them?
knew that. I kind of like it was an instinct of mine.
Yeah, right? Because they're so much fun. Do you guys know the diagram sentences or no? Diagramming sentences? Did you ever actually? Oh, love that. All right. So what's the answer here? Yes or no? No. Are you convinced? Yes? Yes. Mark is like, let's move on. I'm done with this. All right, go fast. Go fast. Let's move on.
Oh yeah, I said false. I said false. I said false.
This one on my own.
I just said no.
Because it would not be.
I said that this would be.
True or false? Talk about it. Talk about it. Talk about it.
Yeah.
It's like a septic song. It's really not a good one.
It can't be going, that's, no.
It's just a time spot.
Yeah.
You should notice it.
I noticed it.
Take a time stick.
All right, are you done?
Yeah.
Got an answer? You guys are done? Yeah? What did this table say? Oh, true. These ladies are saying true. What'd you guys say?
False.
False.
We said, I said, oh, I say false too.
False?
Oh.
Yeah, we said true.
Oh, so like the room is divided. That's interesting. Oh, but Nam, you're on that side of the room? Okay. All right. We've got lots of dissenting opinions. Discuss. Tell me why. What's the right answer?
Hold on. Can I say something?
Of course you can. No, you may not speak. Of course you may.
Okay, I think it's true because even though it got lifted up on the table, it's still exerting the same amount of force because that is Newton's law. We mentioned the same thing as the skateboard. It's not like you're not moving when you exert the same force, but it's going to have a bigger acceleration due to the mass.
Okay. Did you guys all follow that?
A little bit.
I was kind of there.
Do I need to
Tell me about the forces. What's the first force?
Potato.
potato?
The-
On the table.
Okay, hold on. Is lifted off the table
Just ignore the potatoes.
by a hand, exerts a force on the potato. That's the first force. Are you with me there? On the potato by the hand. Yeah? What's the second force? Shh, guys, please.
On the hand by the potato.
On the hand by the potato. Is that a Newton's third law pair? It is.
But, so Earth isn't involved in this? Then?
Not in this one. I mean, now hold on. Let me back up. Let me back up. If I was going to draw a free body diagram of this potato, and so there's a hand, and the hand is pushing up, force of the hand on the potato, and there's a force of the earth on the potato. That is an accurate free body diagram, right? But in this question, are they asking anything about a free body diagram? Are they asking anything about the earth? They're not. Does that make sense?
Yeah.
Mistakes are okay, right? That's why we do this.
Yeah.
Are we okay with this now?
Yeah.
Yeah?
Take some time, but yeah.
I know, that's why we do it, right? If you just, friends, if you guys just knew this stuff when you walked in the door, then I would be out of a job, right? So that's why I'm here, and that's why we do this. Okay. Questions? We okay? Okay. We'll put some, not really numbers, but kind of more numbery stuff on this, make sure that we're okay. I've got a couple more things. Oh, unless you want to do something different. I mean, it's up to you. I've got lots to do, so you tell me. I thought this would be the best. Oh my gosh. I suppose, go fast. Leave your phone here, though.
Yeah, sure.
Just set it wherever. All right. Okay, we got some little trucks. They're cute. The next unit that we do is or not, the next chapter we do, it's in the same unit, is very much related to this, and it's very much related to collisions. We're going to start it tomorrow, I think. But right now, I just want to talk about this. We've got these two cute little trucks. Without reading anything, you've got a truck that's moving at 4 meters per second. You've got a truck that's moving at 3 meters per second. What's going to happen? Just kind of imagine what's going to happen there.
You're gonna slam
They're going to slam into each other, right? Are you with me there? One's going slow, one's going fast. Yeah, it's going to boom, right? Okay. When they go boom, there's going to be an interaction between how many objects? Two objects, which means there's going to be how many forces? Two, right? A is going to hit B, so A is going to apply a force to B. Is B going to hit A?
Yeah.
Oh, it is! Because can A hit B without B hitting A? Not possible. I haven't sold this little bit of knowledge to you, but I'm going to sell it to you right now. I love to teach my daughter about physics. My older daughter, my younger one doesn't care yet, but my older daughter's like, Mom, teach me physics. And there's one piece of physics knowledge that I will not teach her, but I will teach you guys because you're not my children. And that it's kind of a sibling dispute situation. And that is...
You're gonna help us win every argument.
Right, this is what I'm talking about. Okay. And it kind of has to do with your siblings and then your parent, right? So I imagine, see, I'm an only child. So I didn't ever have siblings to fight with. I had plenty of friends to fight with, but not siblings to fight with. So there's like that sibling rivalry thing. But my understanding is that between siblings, there's a lot of like nitty, like silly fighting. And that sometimes it like ends up in like pushing and shoving and forces of being applied. Yes?
Oh, worse than that.
Well, I'm just saying like it can. So here's the thing. My understanding from watching movies and things like that is that there might be a situation where like, oh, I hit Tatum and she totally didn't deserve it, right? And she's just like, going about her business. I just go up and hit her because that's what siblings do, right? And then what does Tatum do? Either she clocks me back or she's the kid that's like, Mom!
She was that
Right,
kid.
right? Sister hit me! So here's the thing. Now, here's the thing.
I was
And then there's that like, and then your mom's like, well, just work it out. And but she hit me first. Are you with me here? Okay, so here's the thing. When I hit Tatum, yes, I hit her. I shoved her. But she's shoving me back. Who hit first? Right? So your poor little sibling or big sibling are like, she hit me first. You just like, actually not. Like, you know what I'm saying? You see where I'm going with this, right? I mean, it's not like a huge loophole, but it's a little bit of a loophole. So I just want to like make you aware of it.
Oh, just
right?
wait till your kids hit himself.
Oh,
and then
I
switch
can't
the other
wait.
one.
It's
I
gonna be-
did that.
Like literally like, wait, what?
Yeah. Yeah, or I'd pinch my brother, I'd really long nails, I'd scratch him to the point where his skin would rip up, and he'd go to tell my mom, so I'd do it to myself, and I'd be like, he did it to me too!
Oh my god.
You guys are terrible children.
Trouble, because my mom would be like,
Terrible little kids. This is all being recorded. You know I'm gonna play this back for your mom.
you
when she-
know,
okay.
we talk about all the time.
Okay, I'm just-
I just used to bite me though. Like bad.
What was the point of me telling you this story?
I'm talking about how.
Yeah. Third law. Okay. So here's my question for you. Hopefully you'll get these right.
Let's not.
During a collision, tell me about the magnitude of the force exerted on truck
Same.
A by truck B. Shh.
Yeah, it's the same.
Less than, equal to, or the same as
3.
B on A.
Same.
Equal to. Why?
Because when something hits something, they exert the same amount of force back.
Third law pair.
They're law pairs, and law pairs are always equal.
This one's different.
Wouldn't it still be the same? Yeah, that's what I'm saying. It's still gonna be the same.
So it's
Good. Look at you. Learning physics. What?
I have a question on the last one.
On B?
Yeah.
Go.
I know that I understand why it would be the same, but back to the skateboard situation.
Yeah.
How when you guys move further than
That's just the amount of acceleration due to mass.
Right. Yeah, exactly. And acceleration is the thing we see. Force is the thing we focus on, which is kind of annoying, right? But acceleration, that's why I write this way, because acceleration is the thing we see. Okay, that's the result. All right, life is good? All right, let's keep going. Part C.
Oh, wait.
Oh.
Read the question.
Acceleration.
Read the question.
The acceleration.
It did say, just to be clear up here, identical toy trucks.
So B would be greater. Wait, I don't know.
Would the acceleration be the same?
Wait.
no, A would be greater.
Because. But they have the same
No, B
mass.
because
And then back.
they might still have the
A is
same.
gonna, and B is gonna keep going because it's all
Yeah,
the
because
same
B
mass
was
and
already
net
going that
force.
way, and A's gonna have to go backwards.
Wouldn't it still have the same acceleration?
Same.
That's what I'm thinking. Yeah.
Right? This is why we do this. Yeah. So the acceleration for A is going to be the force on A divided by the mass of A. And the acceleration for B is going to be the force on B divided by the mass of B. That's all it is, friends. Does speed go in there anywhere? Does direction of travel go in there anywhere? No. How do the forces compare? You just told me that earlier. Same. How do the
And
masses
mass is
compare?
the same. So
How's the
it's
acceleration? Same. Yes. Same.
See, I want this problem.
Oh, good.
Put this on.
I don't like
Everybody feels differently. Okay. One more.
It still would be the same.
She's trying to trick us.
I'm just
Yeah.
asking you a question.
I feel the trick.
What's the answer? What do you think?
Same.
Same? Same.
Okay.
Same.
Trying to trick us.
I'm not trying to trick you. Okay, I'm going to show you one thing real quick. This is not you have to write it down. This is from your book, but I think it's kind of interesting. I don't know if you've seen it. I'm sure you guys have been reading your book very, very carefully.
Oh, definitely.
Right, so that's why I put it up here because I, was sure you did. All right, so take a look. This is a little comic that takes up a whole page, but I want you to read this first two frames, and then I'll show you the next two. But I want you to take a look here. So we've got this little guy.
Futile. What is that?
Futile, like.
Futile.
It doesn't matter. It doesn't. Yeah.
Yeah.
So pay attention, guys.
Yeah, I don't like this.
I don't
The
like
eyes
that.
are just throwing me off.
The horse's eyes.
Yeah.
Do you want me to read it to you? You can close your eyes. I can read it to you. So he says, "It's not worth me trying to pull on the cart. If I pull on the cart's gonna pull back on me. Newton's third law, right? Horse pulls on the cart's gonna pull on the horse. How are the forces gonna compare? They're gonna be the same, aren't they? It's a Newton's third law pair.
But what about the mass?
A zero net force is not gonna get us to go anywhere. So let's take a look at what he says next.
Physics, blah, blah, blah.
I don't care about the forces exerted on
He's not very kind, is he?
you. Just in the force.
I hope that
force
works.
makes him pull.
It's the same one. Yeah.
Creative.
Physics.
So how does he move forward? How is the horse going to move forward if he's feeling a force back? Do you guys agree that the cart is pulling a force, like is applying a force to him?
Yeah.
Sure. So how in the world is he going to get to go if he's being pulled back?
Acceleration.
We're just yelling words now. I'm so
Well, like
confused.
she has more mass
He has more mass than
than a car.
Now, I don't know if you guys have ever seen a cart and horse combination. Horses are massive, but sometimes, I mean, my daughters and I are reading Little House on the Prairie right now, right?
How old are your daughters?
I read it to them, like at night. 4 and the little one doesn't really, whatever, but my 4-year-old really likes it. But anyway, so there are 2 horses pulling like an entire covered wagon. Are you with me there? Covered wagon probably has more mass than the horses. Yeah? How does this work?
See, then I don't know.
Actually, I made my mom read Little House on the
Friction.
Prairie in one night.
Friction. Don't say that.
Friction is the right answer.
Yes.
I think
Yeah.
I like friction.
I don't even know.
The horse is going to push backward.
The wheel.
The horse is going to push backward on the ground.
The wheels.
It'll be okay. Have a wonderful day, you guys. Thanks for a lovely day. I'll see you tomorrow.